Okay, thank you very much for this introduction. Thank you also for inviting me here. I will start a little bit because I'm not sure if everybody knows what is wastewater-based endocrinology, so I start with what is wastewater-based endocrinology, and I think this image explains it quite well. Everything what we consume got metabolized and will end up in the sewers. And by measuring concentrations in sewage water and taking into account metabolism and flow data, we can make an estimation of consumption. So actually sewage wastewater is kind of a fingerprint of us, and it's not only to illicit drugs or lifestyle habits, but also exposure to pesticides, for example, and other public health applications. So the application most known is illicit drug use, what we did in Europe since 2011. I have some data. Last year, for example, we have 27 countries participating, 85 cities, which covers more or less a population of 38 million persons. And Cyprus, I marked it here, they also participated. Limassol and Nicosia, I think my chairman just explained this, but it was a good example. We have a great support of the EMCDDA and also UNODC. They reported in their annual reports, EMCDDA since 2014 and the UNODC since 2016. We have a website as well. Our group is called SCORE. And EMCDDA, especially, they have also a really nice dedicated part in their website. It's very interactive. But there is also a small video explaining what is wastewater-based endocrinology. They have facts, so frequently asked questions. And you can see, for example, by drug, you can see the mean of a weekday or weekend day, by year, and by individual day, because we normally take 1 week at the moment. Now, we want to apply this also to new psychoactive substances. In case you don't know, these are compounds which may mimic effects of the illicit drugs, but they are often not yet controlled. So there are about, in the last decade 700 MPS reported to the early warning system of the UNODC and of EMCDDA. And one of the challenges and limitations in monitoring in general, also in blood or urine, but of course also in wastewater, is that the number of consumers are generally small, so concentrations are low. Users do often not really exactly know what they consume. There's a lot of information on the products, but they are not always corresponding on what it really is included. And there's a lot of lack in data and metabolism, so it's difficult to have targets. Besides, it's a very dynamic market, so if some MPS appears and there might be a law, which is per country different, there might appear a new MPS in the market again. So you need an analytical challenge. It's an analytical challenge, so you need a good strategy. And I'm an analytical chemist, so I promise that I only do this slide on chromatograms and so on, so please don't run away yet. Afterwards I won't repeat it. So as a screening, we use an ion mobility with a high resolution mass spectrometer, which allows us to not have all reference standards available, so you don't need a prior selection of reference standard, and you can actually screen for any MPS or metabolite, even retrospectively, so after a year you can look back at your data if you have more information on your metabolites, for example. So we use ion mobility, for the people who don't know, first the high resolution, so you have the exact mass of a molecule, of the molecular formula, and with ion mobility you can look at the shape and size. This is very useful for isomers which are present in MPS, because it's depending on the position sometimes of the chlorine, you can still separate it. And before this instrumentation, we also have chromatograph, so you also look at difference in polarity. I want to show this because it's important to know that we really have a lot of information to get to a tentative identification. But finally, for confirmation, we need a reference standard. So this we can buy sometimes, they are not always available, but sometimes we can purchase them, and otherwise we need to synthesize them. At least you don't need to buy all 700 MPS, that will be very expensive. So this is a good strategy, I think, to look for these compounds. Once you have a reference standard, you can set up a quantitative method, mostly by triple quadruple, so which we have for about 30 MPS. So in this study we monitored MPS and also illicit drugs in several music festivals. We collected pooled urine and wastewater across Europe. Most of all festivals, they had a zero drug tolerance. We had a common protocol, so we used for all samples 4 approaches: hydrolysis, dilution, and different ways of SPE, a more generic and a more specific SPE, solid phase extraction. Sorry, I'm a bit into the analytical part. So once we inject them, and I will go quickly now to the results. I've submitted this paper, so there's some preview of it. We measured some samples in the UK, where we found several drugs of MPS. I mean, this is a sum because we collected from several pools, several toilets, grab samples, so we had to sum up the concentrations. There are different systems that you have to handle with what you get. So we found several drugs. Most prevalent was alpha PVP, but if we compare it to the normal illicit drugs, we clearly see that they are much, much higher, 40 times, for example, alpha PVP to MDMA. So we could say that we might not substitute, but they are used, and it's a screening to monitor if they are used in these kind of settings. So for Portugal, we collected wastewater. We also had a survey data for about 887 persons, and some corresponded in the last 48 they have consumed synthetic cannabinoids, others piperazine and plants, and nobody said synthetic catechins. However, we saw these are loads. We saw that we found mostly synthetic catechins. This can be, of course, of different reasons. The wrong people were interviewed, or maybe they didn't want to admit that they used synthetic catechins. They were just not available. So here we can see that we found these synthetic catechins. We also have an interview with, for the normal conventional illicit drugs. So many people admitted to have used cannabis. Also some people cocaine and MDMA. If we look at wastewater data, here we see a week of prior to the festival, so there's no influence of the festival. That's the dotted line, and the continuous line is when the festival took place. And you clearly see here that the data of the survey more or less also confirms what you find in the wastewater. There's a high increase in cannabis. The cocaine is more or less starts more or less at the weekend level. And for MDMA, you see in a normal week a high peak during the weekends, and also in the festival, it's a bit spread. The same we did. We don't have survey data, however, of Spain, but we did it of a small festival in the north of Spain, where we didn't hardly observed consumption of cocaine and no MDMA, but during the festival it increased a lot. And especially what we found interesting was during this Spanish festival, the increase of ketamine was very significant. So, as I said, you can also do retrospective analysis. My colleagues from the Netherlands, they had information that 4-fluoroamphetamine was substituted by 4-fluoromethamphetamine, and by looking at the data, we indeed found 4-fluoromethamphetamine as a substitute of 4-fluoroamphetamine. Furthermore, we can look at emerging contaminants. You have a lot of data. You can also look at new by common fragments and so on. And we found this polymeric carbohydrate. And then going back to the festival organizers, we asked if there was something curious. And DFF, we called it, which stands for Dutch French fries, because people were smoking the French fries, and this happened to be that there were some polymeric carbohydrate. So an overview of the MPS identified, as I said, we see a lot of catenones and phenylethylamines. We also found some other MPS. Little synthetic cannabinoids. This is, I think, mainly because there are many synthetic cannabinoids on the market. They are strongly metabolized, so concentrations are very low. So in wastewater, we are not able yet to measure them. So we need to get more, try to improve our methods to analyze them. As a conclusion, well, as I said before, we have a lot of challenges and limitations. The rapid transience of the drug scene, lack of data, and the low concentration. But the LCMS, what we use, is a powerful tool, especially to monitor pooled urine and wastewater, because you have many potential users in one sample. There's a lot, you can monitor a large number of compounds with a high resolution. Well, I'm in conclusion, so I would like that. We can look retrospectively and even look at new MPS, and especially if we have more information of new metabolites, we can look retrospectively. And it doesn't seem that MPS really substitutes, maybe in a small percentage. I think this is not only conclusion, maybe also take home message. I think it's very important to do data triangulations, like I said, like you could see with the survey data of Portugal, because wastewater basin really has some clear disadvantages. We have no information on single users, on the age, or the gender. We don't know the behavior of single users. But we can get anonymous data near real time. If we take a sample today, then in theory tomorrow we can have results. So it's really quick. We can monitor drug trends. And one sample represents really many compounds, like you see in the European drug monitoring. We can manage to measure more or less a population of 38 million. So this is relatively cheap for that reason. So it's very complementary to other tools we have, I think. So we do acknowledge all the people who provided samples, especially my Dutch colleague Erik Empe and my PhD student Alberto, who did a lot of this work together with me